Okay, so welcome everyone. We're going to introduce ourselves first and then talk about turntable, tone arm, and cartridge setup, basically. So my name's Mike Trei. I'm a columnist in Stereophile magazine, and it's called Spin Doctor, my column. And I talk about turntables, tone arms, cartridges, phono stages, and various related things. But on a more practical level, I go out and I set up turntables for customers in their homes mostly. And I fly around the country to do that, and I've been doing it for 40 years. So I have a fair amount of experience. I've set up thousands of turntables and cartridges.
How much does it cost?
Well, we can get into that later. But mostly in the New York City area, but I do go far afield as needed. So I have a lot of experience with different brands, models, cartridges, probably more than most people. So a lot of practical experience. But I'm here with JR from what do you call it now?
WAM Engineering, WallyTools. Yeah, thank you. Can everybody hear in the back? Oh, okay. So I think, yeah, and hold it nice and close. I think we hold it nice and close.
Sounds good.
Right? Yeah. So hello, my name is JR, and I was friends with Wally Malowitz. He was my dear friend and mentor from back in the early 90s. And when I was his production assistant on a number of his products for a while, and when he passed away, I said to his son, who's also a mechanical engineer like his father, I said, hey, I know what your dad did, and I know what he left undone. If you want, we can make a couple Wally skaters and Wally tractors and move forward. And here we are doing it today. I never imagined it would be a full-time gig for me, but I'm a very curious person, and the more I researched into this beautiful mechanical transcription instrument that we all own and enjoy, I realized how much more we don't know about it and don't understand how this multivariate system creates the incredible sound that it can offer. So I wanted to plumb the depths of how far can we push this technology. But the problem is that the more I learn about it, the more I realize how much I don't know, because I keep opening new doors that appear to be perfectly influential to what we hear. The difficult part is being able to understand what are all of those parameters that impact what we hear, and then being able to measure them independently, which is tough, not easy work. But I've assembled with me a number of engineers who are much smarter than me in their various to help in the effort. So today, anytime I get on a phone with you, Michael, you and I, we can't stop talking.
Right.
Because he's got like he said, this decades of experience with many different turntables and tone arms. And it's interesting that many of the conclusions that he's come up to with what is best, what sounds best, I have found, I've come to the same conclusion instead of using a huge array of experience over time and across iterations with different products, I've come to many of those similar conclusions by looking at it more scientifically. So,
yeah. So we came up with a list of questions to sort of discuss.
There you go.
And the first one was, what are the most common mistakes you see in turntable cartridge setup? So often I'll go to a customer's house and they already have a turntable set up, and I'm just there to either change the cartridge or tweak something or make adjustments. And I guess the first thing is the turntable has to be level. And all the time I see they're tilted one way, tilted the other way. And the way I like to level a turntable is the platter itself, the actual platter that you're putting the record on. I use a 9-inch or 8-inch torpedo level, measure it left to right, measure it front to back, and adjust as needed. I actually use one that weighs 160 grams because it's kind of on a suspended turntable like a Lin. That's about the same as a record, so it's going to move the suspension about the same amount. So that's the first one.
And I agree with that. There's some I agree with that, but there's some tone arms where the center of gravity of the arm is far above far below the horizontal axis, and then you have to level the arm board.
Well, the arm board, in a perfect world should be absolutely parallel with the platter.
Yeah, but as we know, this world is far from that.
Sometimes isn't.
Yeah,
There's some turntables where you can adjust that. Like on an SAT, you can adjust the leveling of the arm board.
That's true.
And you want to make it match the platter itself.
Yes. I agree with that. The lack of levelness is one thing. The other is a lack of attendance to just getting your tracking force right.
Right.
It's surprising how often when I get somebody who is calling me say, "Hey, things just don't sound right." 80% of the time, when somebody calls me or emails me with just the query of why is my turntable sounding off, I take them through a 2-step process, and 80% of the time, it will satisfy what's going on. First, I tell them, make sure you've got a good scale with a calibration weight and a fresh battery. Sometimes some of these, like the Riverstone Audio, which you and I both use frequently, which is a great value, when that battery goes bad, it'll lie to you about what the mass really is. So you got to have a fresh battery, you got to have a calibration weight to make sure that's telling you the truth, and you got to make sure that the level of that platform upon which the stylus lands is roughly about the same height as the record surface would be. Okay, once you've established that, a lot of people say, "Oh, wow, well, I'm up at 3-point-something grams when they're supposed to be at 2," or "Why am I getting 0.7?"
Right.
Okay, well, we check these things, and these things, who knows why they change over time? You might have inadvertently bumped the counterweight and never known it at some point, right?
But going back to what you were just talking about tone arms where the center of gravity is above the pivot. Classic example is the Kuzma 4-point.
Yes.
That arm, if you move it up and down to adjust your stylus rake angle or VTA, that tracking force is going haywire when you do that.
Oh, yeah,
More
absolutely.
than any other arm. You move it up 2 millimeters and it's 0.2 of a gram difference.
That's right, and your VTA never changed.
Right. So
because your tracking force went up.
That's why it's super critical to have the measuring platform of your scale at the exact same height as the record surface. So
Yes.
the nice thing with the Riverstone is you can actually bend the thing and tweak it a little bit and get it so that it's the same height as the thickness of a record. Yeah. So when you put it on the platter without a record, it's exactly where you want it to be.
Yeah, exactly. And then the second step I take them through, and the people are complaining about something just not sounding right, is put that arm on a Wally skater and measure those horizontal torque forces. And that's where often the problem is often found, but either in high bearing friction or way too much or way too little anti-skate force, which causes a force multiplier on the damper. And the damper is, I think, the most neglected part in the whole system of turntable transcription.
So the next thing I see a lot is loose cartridge clips.
Oh,
the 4 wires that connect to the back of your cartridge. People slip them on and they think, "Oh, okay, it's making contact." Now it's got to be pretty firm and tight on there, or you're dealing with such a low level signal and a very low impedance output that you have to have a nice, firm, clean contact there. So you got to get tricky with needle nose pliers, squeezing them to make them tighter or prizing them apart to make them a little looser.
I have a story on that just occurred this last week.
Yeah.
I had a client who was complaining to me about sibilance. Now, generally, when I hear this problem with sibilance, we can solve it most of the time with a Wally skater. It didn't solve it. The Wally skater was telling him everything was fine with the torque forces and the friction of the bearing. So I said to him, "You are now in a very small class of people who I'm unable to help you with this sibilance problem." He stuck at it, and he found, I didn't think about it, he found that the clips, he had a removable head shell, and the clips that went to the pins on the head shell, that they were very loose. And when he took them off and replaced them with a different set of clips, the sibilance went away. It was actually, think about that, the mechanical connection between the pin and the clip was rattling.
Really?
There was so much energy being transferred from the stylus to the cantilever that bypassed that most critical part in the whole system. The pivot point went up through the head channel, was rattling the system around enough to make 2 pieces of metal that were pretty loosely connected to each other shake against each other and give him the sense of sibilance. Rare situation, but it goes to your point. Keep that snug.
I mean, that type of head shell, the SME or H4 removable head shell. It's a really old design. It came out in the 50s, and there's a lot of problems with it. You got to make sure all those connections are really clean and not corroded at all.
Yeah,
because the pins in the head shell have little springs on them, and they're supposed to spring in and out to put pressure on the pads in the end of the arm. And that can be a problem area too.
And by the way, we're going to open this up for questions for the last 20 minutes.
Right, towards the end. And carrying on from there, just the cartridge has to be screwed in tightly. I go sometimes and I can just slip the cartridge around with my fingers, and it's just not tight at all. And then their alignment settings are all out of whack. So, I do them up pretty firmly. I mean, there is a sonic change when you torque the screws, and you can use a torque wrench if you want to get fancy. But I sort of got my own hand-built personal torque wrench in my hand, and I sort of know how tight sounds good.
Got a good feel for it
most of the time.
Yeah. And there are actually some tone arms out there. I won't name any names, but there's some materials that the head shell is made of that doesn't have a memory. So when you screw down and you tighten the screw, over time that material will remember its position, and that screw will no longer be torqued down. You have to, every few months, just make sure it's torqued down. So make sure that's not you. So keep an eye on the torque on that screw. Would you agree with that?
Absolutely. Certain head shells that are not metal that tend to compress a fair amount. I got into trouble with one of those because I set one up and I started using Loctite on the screws with that tone arm to stop the screws from backing out. And then the guy had a problem with his cartridge. They sent the cartridge back to the manufacturer and they say, this isn't covered because this cartridge has been modified. Someone used Loctite to hold the screws in. So you can't win.
Yeah, I know how you probably felt really bad about that. I've been in such a similar situation. Yeah.
So what else we got? Which adjustments do you think are the most important?
Well, I think torque force on the cantilever is highly important.
Yeah.
And that damper, as I mentioned before, is an underappreciated component inside of the cartridge that has a lot of influence on the quality of sound that we hear. So making sure that our torque forces, and I've done many videos on this, right? Torque forces on that damper are such that with the skating force, the compression is equalized on either side of that damper. So that's one. But I don't know if it's hard for me to commit to a hierarchy.
Right.
What's your idea?
Well, tracking force is super important, and that's when people get it wrong a lot. I think overhang and alignment is maybe less important,
Okay, yeah, I think we can actually agree on some of this. So this is going to be interesting. So let's make sure we get into that.
And what brought me to that was I reviewed the Viv Labs arm, which is a straight arm. It's underhung, and it's, tracking angle error is all over the chart. I mean, it's got one point where it's right, and then everywhere else it's really wrong. Up to like 4 degrees or 10 degrees, I think is the maximum.
It gets pretty bad.
Maximum tracking angle error. And it didn't sound horrible, Nope. I expected it to send me out of the room, and it didn't.
That's right.
So then I'm thinking, when we're adjusting to 1/10 of a millimeter, how important is that? I think it is important, but maybe less so than I thought before.
Yeah. Okay. So and I did a video on this issue too,
right?
Because there is good reason. So one thing I try to convey to my audience and my clients is that look, the wonderful thing about this transcription system that we all enjoy so much is that you can get wonderful sound and be perfectly misaligned. My driving ethos isn't to improve your sound. I don't care about improving your sound. I care about optimizing it. Now, what does that mean? That means that I believe that there are specific and measurable goals to aim at once we understand what those parameters of aiming are. Right? Now, in the case of the Viv Labs one, wonder, it's violating all of these rules, right? On overhang and cantilever alignment, and forget about the zenith error, that's going wonky as well. And so why does it sound good? Well, it has other advantages that it's playing at, right? For example, it is because when its maximum skating force is going to be at the inner and the outer area of the record,
Right.
but it's still lower skating force,
like
quite a bit
110.
lower
Like
than what you would get with a normal pivoted arm. What does that mean? The damper remains pretty much optimally symmetrically compressed the whole way through. So already the damper's got optimal situation. Well, now we're left with, okay, what are the losses? Identifying errors of omission is much more difficult than identifying errors of commission. And I think you, like most people who understand the transcription process, probably expected to hear errors of commission.
Right.
And we didn't.
I expected tracking angle, tracking distortion, tracing distortion, I guess it would be.
Yes, well, I believe, and I don't know, I can't speak for you, but I believe what a lot of people refer to as inner groove distortion is actually a tone arm torque problem. All right, it just becomes more obvious there, right? But actually Michael Framer and I, we did a little experiment on this, on what happens with when you do have a lot of angular error at the inner area of the record. The losses that an arm like the Viv Labs would experience, it's less of everything. You get less clarity, less focus. The separation between instruments becomes less clear. The size and the back wall of the hull in the studio, in the recording studio, become less clear. It doesn't mean it doesn't sound good. It's just a diminution of things. Clarity and focus reduces. If I could take that Viv Labs arm and show you for how wonderful it does do a job, and then quickly correct for the errors, you'd hear it immediately. It's it's an error of omission, not commission. So it's not to say that it sounds bad. It's just not optimal.
I think what they do is they actually, so it does have a single null point, and they put it about 2/3 of the way across the record. So the tracking angle error at the end of the side is actually not nearly as much as at the beginning of the side.
Yes.
At the beginning of the side, it's like 10 degrees.
Yeah,
on
it's
the
bad.
9-inch version.
But that matters less at the outer.
And then at the end of the side, it's about 4 degrees.
Yes. So they're biasing.
Even a regular 9-inch, overhung arm, it's about 2.5 degrees. So it's not like you don't get any.
That's right. Yeah, that's right. Yeah. So look, everything we do is a balance. I'm not willing. I don't like to compromise. So I'm looking at ways to have my cake and eat it too, right? And so an arm like that, I can enjoy the music, but I know that I will be missing something. And so I'm unwilling to live with it. It doesn't mean you can't enjoy the music, right? So
I think a lot of, with an overhung arm, a more traditional arm, it comes down a lot to how well the anti-skating is designed. And they vary all over the place.
Oh, they really do.
From non-existent to,
disasters.
things that will pull really strong for the first half of the record and then just drop off to nothing.
Yeah.
Or ones that will actually push out from the inside of the record. And,
yes.
There's some really bad designs of anti-skating.
There's even one anti-skating device that the arm behaves beautifully on the Wally skater until you turn on the anti-skating and then it locks up.
Right.
The static friction goes through the roof, and we're talking what they're most expensive, like $60,000.
Right.
It's unacceptable. Yeah, it's just, ouch.
Anyway, so another question was, what's the difference between Berwald, Lufgren, and Stevenson, or even,
I'd love to hear
even Uniden or whatever.
It kind of plays into the conversation we just had, right?
And how important are they?
Yeah.
And, my argument is always that, so Berwald and Lufgren were doing their papers around the same time in the 30s, long time ago. And they were dealing with 78s and they were, mono records, wide, but, with, SP groove, a standard groove. Stevenson did his paper, I think, in 64. So it was early stereo era, and any sort of person that was paying attention to this stuff in 1964 and was an audiophile was probably listening to classical music. So his thinking was he wants to put the least tracking angle error and inner groove distortion at the very end of the side when they're having the big bombastic end of the movement of the symphonic work where it's getting really loud. And so he put that, and then he compromised by having higher tracking angle area across the rest of the side.
Yes.
And I think since then, even classical records are not cut as far. I mean, who's cutting classical records today? Not too many. But
Yeah.
records in general are not cut as close to the label as they were back then.
This is true.
So, I tend to veer more towards, Bearwald, which, technically is Lufgren A.
Yeah, true.
and Lufgren B alignments. And Lufgren A and Lufgren B are kissing cousins. They're almost
yes.
identical.
Yes.
And Uniden actually falls right in between them.
Yeah.
So any of those three are pretty much the same, and then Stevenson is a little bit of an outlier. But I tend not to use Stevenson much.
Yep.
I mean, there's some arms that are designed for it. If you have a Riga arm, it's kind of designed for that. And sometimes you can't get the cartridge forward enough if you're trying to do it in a different alignment.
Yeah.
So you're kind of stuck with using Stevenson. Or if they have an older SME arm, they use that as well.
Yes.
So
Yeah.
I don't know if you have any thinking on
so
that.
I did a video called "Why We Don't Use Stevenson Alignment."
Okay.
Yeah,
I didn't watch that one.
I've got I think pushing 100 videos now, all of them real short. Try to keep them short, but so I don't believe it's worth. I'm just going to give you the end point of that video. It's not worth arguing over. The difference is, it's like arguing over a molehill when there's a mountain of other issues that are more audibly obvious that we can be talking about. Okay, and the emphasis to want to err towards having zero tracking error at the inner area of the groove, where arguably it's more difficult to track a record because the data in the groove is more condensed, but yet the stylus doesn't shrink to accommodate the shrunken data, right? That a lot of, again, I go back to something I said before, a lot of people refer to this inner groove distortion. And I think what most people, when people call me and say, hey, I'm getting inner groove distortion, I ask them, what are you talking about? What does it sound like to you? And they usually have terms like this. Well, it sounds more garbled, it sounds sibilant, or it sounds like things are just falling apart. Well, that's not what angular error sounds like. That's what a crushed damper sounds like. Torque forces in the arm are out of control. So almost always taking care of measuring those torque forces manages that issue. So I think a lot of the drive towards but you see those issues that then become more audible expose themselves more easily, the issues of the damper being asymmetrically compressed, expose themselves when the data becomes very compressed there. But the problem isn't the misalignment, it's the arm has been torqued incorrectly the whole way across the record. You're just noticing it now, where the data is compressed. All right? So let's fix the real problem. So I don't think that, and then when people say, some people say, well, I realigned the cartridge and it fixed itself. And I say, they didn't hear that same level of a problem anymore. And I say, I believe you. Why? Because you might have, by chance or by design, usually by chance, more properly aligned the two contact points in the groove so that you had less zenith error at that point. What zenith error causes is a vertical excursion in the groove where there is no vertical content. So anytime you've got a vertical excursion, whether it's caused by the groove wall or by zenith error, you're creating an upward vector force that makes it easier for the cartridge, the stylus, to momentarily lose contact with the groove wall. And that is audible as sibilance or mistracking. So sorry, that was a rather,
that's cool.
Rather long explanation. Hopefully that was understandable.
Another thing I came up with is, it's not really a setup mistake, but a problem I run into all the time. So people say, oh, it doesn't sound right, blah, blah, blah. I go up there, they just got a dirty stylus.
Oh, yeah.
And people think they're cleaning their stylus, and they're not doing the job properly. I'm really off gel cleaners. I know they're really safe and easy to use, and everyone likes to use them because they feel they're going to damage it if they're using some other method, but they don't really work as advertised in my experience.
Yeah,
Some are better than others, but
yeah, as you may have known, I worked with the fellows from Onzel
there was a whole
yeah.
brouhaha, but
and when they sent me, just to be fair to them, we put that material through something called infrared spectrometry to understand what it is and understand, okay, why is it occasionally, but not always, releasing its material to the stylus, right? Which then, will end up in your record, right? What we found is that the degree to which it would release from that mound of gel to the stylus was rather chaotic. Like, we couldn't get it to consistently do that. But when they sent us samples from the factory that were fresh, I couldn't get any transference at all.
Right. So
none.
If you have a gel cleaner, I would replace it once a year.
Yes, that's the key.
That's, don't have one that's 6 years old. They start to get opaque after they get old, like it's not clear. And then I've actually seen them where instead of being convex, they sort of collapse and become concave.
Gosh, yeah.
No, just throw them out. I think the DS Audio one is better.
I don't have an opinion about that.
It's a little more pricey, but it seems to work well. And this Audio Technica has one. I haven't really played with that one.
Yeah, but do replace them.
Yeah.
Because there are oligomers, and that oligomer chain can shorten over time. But we just didn't have any resources to determine what causes the oligomer chain to shorten. Is it just time? Is it heat? Is it UV exposure? Don't know. Just replace them. If you're going to use them, please replace them. Yeah.
But, my preferred method for cleaning a stylus in most cases is one of those little round pad type brushes with a drop of fluid on it. And the fluid I like to use is the stuff that Audio Intelligent Vinyl Solution sells.
I use that in the lab.
Or I think Sierra Sound sells this exact same fluid. Mm-hmm. I like the AIVS bottle a little better because it has a dropper cap on it, so you can just put one drop on.
Yep.
And that stuff, it doesn't have alcohol in it. I think, I get very nervous about using alcohol fluid because some manufacturers will tell you, don't use any stylus cleaning fluid. And I think they're worried you're going to use alcohol and it can help dissolve the glue and make your stylus come off.
Yeah.
I've almost never seen that, by the way. I've never seen a brush pull a stylus off. And people say it happens, but I've never seen it. And I used to use the MoFi number 9 fluid, which is
straight
super
alcohol.
Heavy alcohol.
You can smell it.
You could get high off sniffing that stuff, and I never had a problem. But I prefer they call it an enzymatic stylus cleaning fluid now.
But even if you just use distilled water, I'm cool with that. Yeah.
And then if you really want to get heavy duty, I'd written about the Chinese company Humming Guru makes. Everyone talks about ultrasonic stylus cleaners, these little vibrating pads. They ain't ultrasonic. If you can hear the damn thing, it's not ultrasonic. It's just a vibrating pad. But there is a true ultrasonic stylus cleaner on the market made by Humming Guru called the Duo S. And you put a little drop of water in there, and then you dip this thing in there. It's dangerous as hell. You can slip and break your cartridge really easily, but man, it works.
It does. Yeah.
I had a cartridge that it was a Shelter 501 that was just so baked on. The customer had said, this thing's shot. It doesn't play anything. I tried traditional methods to clean it. It was just caked in like black goo and, lacquered on stuff. And 3 runs through the Duo S and it looked like a brand new stylus.
That black goo stuff, I found that interesting.
And it gets the debris from the gel pad off too.
Oh, really?
Yeah.
Oh, well, that's really interesting.
Yeah.
Okay. If you live near a very busy roadway, I find that there's a high degree of correlation between if you live near a very busy roadway and you've got a turntable in the room facing that roadway, the type of dust you gather from your grooves is this black, oily, sticky stuff.
It's a New York City thing,
Well, that's where I first discovered it, from somebody who lives near Riverside Drive.
Right.
Yeah, and he said, why does my cartridge sound so bad? Can I send it to you? It was coated in this black soot that was very difficult to remove. Yeah. And apparently he got it there at all because he uses a record as a dust guard for his platter. And one day he went on vacation and his son had a party and he believes that somebody played that record. So all of the Dust. I said, is the dust on the Riverside Avenue facing part of your apartment different from the one on the other side? He said, yes. It's kind of greasy and oily on that side, and on the other side of the apartment's like more like normal dust.
Yeah.
So, that's what now on your Stylus.
But along those same lines, I recently got a call from a restaurant where I had installed a Macintosh turntable a couple of years ago, and they said it's running slow. It doesn't sound right. I go there. The bearing of this is in a kitchen that's sort of part of the restaurant, and the turntable is sitting 2 feet from the grill.
Oh, no.
And the platter had got soaked up so much grease from the cooking that if you took the belt off and tried to spin the platter, it would only go half a turn and then just stop. So I had to take it all apart and clean the bearing, and then it was fine, but this cleanliness is really important here,
Yes. This transcription instrument that we play with, it absolutely amazes me the degree of sensitivity that it has. We were doing some displacement tests on head shells using a very sensitive accelerometer, and I'm measuring what does that acceleration translate to in terms of displacement, and we're down in the picometer range. Now, picometer is 1,000 times finer than a nanometer, and there are 1 million nanometers, so there's 1 billion picometers in the thickness of your credit card. It's unbelievable.
Yeah,
and this stuff is audible.
The smallest deflections in the groove are smaller than the wavelength of the light.
That's right, yes.
It's really tiny.
It's unbelievable.
And I just wrote, my last column was about vibration and, keeping external sources of vibration away from your record and where the stylus meets the record.
This is a rather misunderstood
It's something that's ignored by a lot of turntable manufacturers.
Oh, gosh, yes.
We have turntables that are rock solid from the platter surface to the shelf it's sitting on. There's not an iota of isolation there. And so whatever is coming up through your stand from the floor is going straight into that thing and into the platter.
Yes.
And I think it has to be isolated somehow.
Yes, absolutely.
You need some kind of platform that has some compliance in it. Just a board with spikes. It's not isolating.
No, that is not isolation.
It's got to have something compliant in there. I just reviewed this very expensive German platform that does a great job, but it costs more than most turntables. So
yes, yeah, unfortunately,
yeah. There are just buy a butcher block and put some sorbothane feet under it. It works really well.
Yeah,
it's going to cost you $50.
Yeah, and it's heading in that direction, right? But the sensitivity of our turntables goes down to near DC, okay, in terms of its sensitivity to displacement. Will translate into something that we can hear. It exists at our noise floor, so we often don't even notice that it's a problem until you remove it.
Well, that's it. It's masking the low-level details that make the difference between a ho-hum turntable and a really good one.
Yeah, but just have a skeptical eye anytime you're looking at evaluating for purchase a product that says, well, this is an isolation product, okay? Well, okay, first of all, if it's a rigid isolation thing, certainly a spike is a great example, there is no isolation. It just changes the mechanical impedance between the payload and the support surface. What does that mean? It changes the spectra or the nature of the energy that will transfer. But energy will still transfer.
It's a coupler.
It's a coupler which changes the spectra of that energy transfer. That's all, right? And then if you get something that has some compliance to it, you have to ask for test data from an independent lab. You'll rarely get it in this industry, but we want to know how low of a frequency will it still be effective at? Because we have to worry about the single-digit hertz, because those translate into very odd. Those are footfalls. Okay, those are the washing machine churning upstairs, the sump pump going, whatever, right? These things exist at a noise floor. You don't even know it, right?
Yeah. So, we had talked about stands and...
oh, this is a good one, yeah.
So most isolation devices are designed to deal with vertical movement, but your stand doesn't move that way. It doesn't go up and down like a piston. If you're even with footfalls, if you're walking around the room, usually if you look at how your stand is positioned, the rear two legs are right next to the wall, which is where the floor is tied to the wall. So that part doesn't really move much. Whereas 2 feet further into the room where the front feet are, it's kind of like a backyard trampoline. It moves a lot more in the middle of the floor than it does right at the edge where it's attached. So what's happening is your front feet are moving up and down, your rear feet are stationary, so your rack is doing this. It's tipping towards the room and away towards the wall. So you got to brace it so it doesn't move front to back or somehow deal with front to back movement. And I found that just putting a brace between the top of the stand and the wall is super effective.
Yeah, it's not optimal, but it's certainly an improvement.
I mean, if you're above an unfinished basement, you can put a prop jack with a 2x4 on top to support right under where the front feet are. That's a better solution.
Yes. I was at a client's place, and he had a Doman turntable, which has a -K in it, which is effective down to, on the horizontal, 1.5 hertz. But yet, a heavy footfall would still cause a skip. Well, I went up to the rack, and first of all, the rack, you take a corner and you do this, and you can see, the rack I can displace the rack a little bit. The floor was a spongy wooden frame floor. And talk to Mark Doman. Mark Doman said exactly what you said. Well, we can't fix the floor. He's not in a position to put a floor jack down there, so put a wood block between the top of that rack and the wall, so at least it won't displace this way. See, these filters, and that's what a -K is, or Seismion, or EVPs from Norman Varney, these things will only work within certain amplitude levels. Once you go outside of that, they're transferring energy, right? So that's what we saw there. So to your point, that's good.
Yeah. Another question I had here is, how do you know when your stylus is worn?
Aha!
And I see people posting pictures taken with their iPhone on Facebook. Does this look worn to you? And I'm going, I can't tell, It's really hard to check a stylus for wear. Most USB microscopes don't resolve enough. You got to have it positioned right. You got to look straight down from directly on top with the exact right lighting to really see that. And
it's tough. Yes.
Yeah, so I don't have a good answer for that question other than send it to someone that has the right microscope and setup that can check it. A lot of retipping guys will do it, but obviously their sort of incentive is to tell you, it's really worn out. You need to have me fix it for you.
Yes. Yeah. And I'm not. I don't believe, and I did a video about this too. I don't believe that a worn out stylus ruins records. I don't believe that at all. A fine line contact.
A chipped one does, though.
Well, a chipped one can, yes. Tough to know whether you've got that situation.
Well, that you can tell with a more basic microscope. You can see if the stylus
you see a flash of light
damaged,
or something. Okay. That's not something I've actually ever seen, but I believe
I have seen it.
Wow. So a fine line contact stylus, once that beautiful ridge line is a 1,000 scale model here, once that's gone, it's basically a conical stylus. And you've got actually a more gentle surface area to interact with the groove wall. It's actually a lower angle of attack when it has to change directions. So I don't believe that causes, I believe tone arms or mismanagement of tone arms cause groove damage, not styluses. But to the point, or to the question, how long does it take for it to decay? I don't know. I recently, this is an interesting one. I had a customer earlier this summer send me a cartridge that was built in the 80s. And he said, it's still the same stylus, same suspension, everything, late 80s. And he said, look, I'm sure the stylus is destroyed by now. I've been using it regularly every week for 20 years, and I bought it secondhand. So I put it under the scope, and lo and behold, I could see there's some wear, but it was really very little wear. So this has a huge amount of time. And so I called him up and said, you say you've been using this cartridge for 20 years regularly every week, multiple times a week? He said, yes. I said, what's your tracking force? Because a lower tracking force will actually, of course, save the life. About 1.7, so he's kind of low. I said, well, how do you... So tell me more. Why do you think this? How did this happen? I had no. He said, I use Stylast.
Oh.
Okay. Now, Stylast is a lubricant, right? It does exactly what it says it's going to do. Save your stylus. However, there's a cost. The question I've got is, how much of that stylus is now in your groove? Right? That's the question. And once you get a lubricant in your grooves, then it becomes an attractant to material, right? So yeah, you can't have your cake and eat it too in this case. The damn stuff works. There's no two ways about it. It would seem from this one example, but it made it difficult for me to say how long does a stylus last.
I recommend against Stylus.
Yeah, yes, yeah.
It's gummy, and I'm worried some of it might get up into the generator.
I use their stylus cleaner in the lab.
Oh, the cleaner's fine. Yeah, that's the number 4, and the Stylus is number 5. Number 4 is fine. It's not a very effective cleaner. It's mostly water with a little detergent in it. But I think the enzymatic cleaners are much more effective.
Sometimes when I need to clean the cantilever for my photographs, I need that long brush, though. Yeah. So if you've got, depending on the profile of your stylus, we got to watch time to make sure we get make time.
We're right at 40 now,
Okay.
So.
If you've got a Japanese stylus like this with a nice, beautiful ridge line, you can expect that it lasts for as long as that ridge line is going to last in the same minor radius until it's gone. And then how long does that take? I'm not quite sure. A Geiger replicant is a wedge shape. So as that wears, it's constantly changing its contact surface radius, which means that it's not going to perform the same over time until it's gone. That's why I prefer the Japanese design, even though you can tighten controls better with the replicant. But to the question, and I think it's an important question. We're working on a product that uses a recording that allows you to measure on your stylus that minor radius and the distance between the two contact grooves.
Okay.
We don't know what the measurement error is yet, but we're working on a product to be able to answer this question.
Okay, that's exciting.
Yeah.
What else we got? Anyway, going back to stylus cleaning, I really recommend using a microscope to examine your stylus. You can buy a very inexpensive microscope that works great.
Yeah, you don't need a
thing on
scope.
Amazon for $40 that will work fine. Just to check stylus cleanliness. That's what I carry with me when I go out, and it works great. I post some screenshots, and people go, "How'd you take that?" Just a little thing,
Yeah, but there's a learning curve. Would you agree that there's a learning curve how to set it up?
Absolutely.
And get the illumination.
Absolutely, get it focused and so on.
Yeah.
But anyway, I guess we're at time to see
take
if
some
anyone's
questions.
got any questions.
We'll repeat your questions so everybody can hear it.
Or we can hand a microphone over. No? You want to do that?
Mark.
So you've talked about how long a stylus lasts. How long does the damper material last?
How long does the damper material last?
I'm using a cartridge now, a Shure Ultra 500 from 1988. It still sounds good, but I know the rubber in my automobile tires is going to be shot at 5 years. Right. How is it possible for the damper material to last?
I got a little story about that. I once bought a Koetsu Onyx that was in a display case in a retail store for about 5 years and had a halogen light shining on it for all those 5 years.
UV on latex.
So it was a brand new NOS Koetsu Onyx signature, really nice cartridge. 0 hours, never been mounted on a toner arm. It wouldn't play a thing. It wouldn't track anything because I assume the rubber just was hard as a rock in there. So I think a lot of times, even before your stylus wears out, your rubber bits can get, to a point where they're not compliant anymore.
And I think the answer is largely dependent on the material chosen. Yes, latex rubber is an organic material that over time, that can be degraded by UV or ozone with our ionizers. How much damage is that doing? It's probably very, very minimal, but it's not nothing, right? I don't even know what damper material was used in my various. I don't ask that question. I just look at other questions. So I'm not sure how to answer that. Yeah.
Yeah, my Lynn dealer said to clean the cartridge, you take this little piece of green sandpaper and drag it carefully over there every couple of records. What's your reaction to that?
Yeah, the Lynn green paper.
Yeah.
Which is actually a 3M lapping cloth. It's a film, I think they call it. And you can actually get different grades of that. And the funny thing is that the original version of that, before they came out with this fancy green paper, they told you to use the striker on a matchbook. And I have seen Lynn was sending their dealers matchbooks with Lynn logos on it, and it was printed. It said Stylus Cleaner and Review Disposal Kit. So you're supposed to take bad reviews and burn them with the matches, and then use the striker to clean your stylus. I mean, I know Lynn have used that method for decades. It's not what I recommend. I don't think it harms the stylus.
I don't worry about the stylus. I'm more concerned about the adhesive.
But I don't think it really cleans the stylus either. My concern is more that, it might get the actual contact area, which is all the way at the very tip. But there's gunk building up around the shank of the stylus and near the cantilever that it doesn't get close to.
Yeah, so, and that becomes an attractor in and of itself.
Right,
you have to get that off too.
So I don't think that's harmful, but I don't recommend that as a method.
Yeah, and if you're using an Orbre made, remember there's only three manufacturers of stylus cantilever assemblies in the world. If you're using an Orbre, the adhesive that holds the stylus to the cantilever comes very close to the tip of the stylus. I don't want to abrade that adhesive away, right? I'm less concerned about that with an Ogura, but I would be concerned about that with a Geiger too. Yeah. So no, I don't like the idea. Who else? Get you next.
You mentioned calibration weights for your testing your scale. Where do you get those?
If you buy the Riverstone, it comes.
Yeah, the Riverstone audio scale, which we like. It comes with the scale, the calibration weights with them. Or you can, for $10 on Amazon, you can get calibration weights from like a quarter of a gram up to 10 grams. Yeah.
What's a good way to clean a record? And the other one is, what are your thoughts on adjusting anti-skate?
The second one's a very big topic.
Oh, yeah. How much time do you have for the second one?
Cleaning records. I'm not fully in the ultrasonic camp, although I think it's got a lot of benefits. My problem with most ultrasonic cleaners is that you're knocking all this dirt into the water, and it's sort of getting suspended in the water. And then you may pass it through a filter before it goes to the next record. But you're just draining the water out and then drying the record with a fan, and it's just evaporating the dirt back onto the record. So, it might filter it for the next record. But I sort of use a combination of vacuum-type cleaner and an ultrasound. I think the ultrasound works well, but maybe for the drying portion, use a vacuum-type machine. I use a Loracraft machine. I use a Humming Guru ultrasound machine. I've had a few audio desks, but they tend to break.
Yeah, they do break. Yeah,
I can make a little wall of them in my house if I wanted to, broken ones.
What do you want to say about anti-skating? You want me to take that one?
Yeah, you take
It's dangerous if you have me to take that one.
That's your topic.
Now, I want to understand the spirit of the question. Because I've done many videos about this, right? And I even I did a series on what causes skating force, which is a combination between friction at the stylus groove interface and something called effective moment arm. So I explained in my videos what that is and how you can identify it and how effective moment arm changes depending on where you play across the record. I don't want to go down a rabbit hole right now, but I'm trying to understand the spirit of the question. Anti-skating is absolutely fundamentally essential if you care about optimal transcription. If you don't, you just want to play music, fine, don't worry about it. I'm not interested in that. I'm interested in getting every possible iota I can get from the groove. And if you're in the camp that believes that anti-skating doesn't matter, I say, I challenge you to listen to what it sounds like with an arm, to have a measured application of proper torque force, and tell me if you still believe that same thing. Yeah, or maybe if it's far away, we could repeat the question.
Yeah, hi. You mentioned in one of your talks that I heard in one of the shows that the wiring inside the tone arm also may be causing some torquing forces.
It can, absolutely.
Any advice on minimize that?
Oh, well, first you got to measure the size of the problem, right? And that's what the Wally skater does. And if the internal wire is causing a significant torque force, and you're unaware of it, then at the time of aligning the cantilever, you will misalign it, period, full stop. It just, right? So in my video, I talk about what to do about it, all right? So I encourage you to watch my videos on torque force and the Wally skater, all right?
So I find that the tone arms that have an external loop,
Yes.
are much more of a problem in terms of torque forces, where you have a little loop that comes out and plugs in somewhere. The dressing of that loop makes huge differences.
Very influential.
And I know, JR doesn't like to use a blank record, but I do, because it really shows you what's happening with those changes. It shows you whether it's pulling from the outside really strong and then just stops halfway in the middle of the record and pushes out from the inside. And you can use that to manipulate and twist the loop to minimize its effect on the movement. Kuzma, Sapphire, Kuzma 4-point, VPI, they all have this issue with that loop. The fancy Wilson Benesch arm, they got really clever. They put the termination for the wires directly above the pivot point, so they don't really torque at all except the twisting of the wire.
To buff my own fingernails here, Craig Milnes wasn't able to decide. It was frustrating for him to decide on which wire to use.
Yeah.
He wasn't able to come to a conclusion until he had a Wally skater. So the Wally skater
There you
showed
go.
him which one to choose.
There you go.
Yeah. But yeah, the reason why the loop of the wire, it's not just the loop itself that causes that extra risk. It's the fact that because the wire is exposed to your fingers, the designer will choose a wire that's more robust against your fingers. You're less likely to break it because it's not as fine. Well, if it's not as fine, it's more rigid, therefore more influential. Yeah.
So my question relates to accidentally forgetting to lift the tone arm when the record's finished. How does that affect the angle of the stylus? If it's on there for 20 minutes or an hour or two.
Yeah.
So my feeling is it doesn't really affect anything except a little wear on the stylus. It's just an extra 20 minutes of wear. I don't think it affects the cantilever angle or anything in any. I had a customer once, I installed a brand new Dynavector XV1S. He left it playing a record and went on a business trip to England for a few days. Came back, saw it was playing the end and lead out groove of a record, called me up desperate thinking he'd destroyed his cartridge. I said, no, you just added 100 hours to it, but it's probably fine, and it was. It sounded fine, The danger you can get into if you leave it there for a long time is if dust builds up on your record. I've seen it where it gathers on the stylus and builds up to a point where the stylus skates onto the label, and then you're in trouble.
Yeah. Well, there's a nice little product for that called Little Fwend.
Yeah, there's a few different lifters that you get.
Yeah. I hypothetically, I could imagine the skating force actually, as you get that far in, that's about 50 millimeters, gets very high. Hypothetically, if you don't have enough anti-skating force, hypothetically, you leave that there long enough and you will cause a distortion in your suspension. All right, but you have to already have probably.
I don't think I've ever seen that.
And I haven't either. That's why I say it's hypothetically.
Right.
Yeah.
Get further towards the back.
We'll get you next.
Maybe pass to the other guy.
So you mentioned about the isolation of the turntable base. What about isolation from above? Is there some sort of like a lucite cover, dust cover kind of thing? Is that helpful, or
You mean from
What do you do?
acoustic pressure?
from the air?
I'm not sure what the size of the problem is, to be honest with you. I don't know. I've never looked into that. I've looked more into, the mechanical, which is much more obvious and easy to read. What's mechanical influence getting? We can use accelerometers for that. But the acoustic, changing acoustic pressure, what you're talking about, I don't know what the size of the prize there is. Hypothetically, I could imagine it's influential. How much so, I don't know.
Talking to that one? Okay. Yeah, so I actually talked about this in my upcoming column. So putting the turntable in another room is the perfect solution, but it's a little impractical because you got to run back and forth. But I had a customer that did that, had set up his whole system in his study, had a hole through the wall with his Watt puppies on the other side in the living room, and it worked great. And I noted when I recently wrote about the Kuzma Stabi M turntable, and they make a point that their dust cover is super thick and designed to sort of block airborne vibration from reaching the record. And they actually tell you to play it with the cover down, which most manufacturers tell you to take it off. Like the Lin people, with the Lin people, there's always discussions, cover down, cover up, or cover off. And cover off is usually the answer. Cover up is the worst because it acts like a kind of, microphone to pick up the vibrations. But I think it is worth thinking about. It's far less of an issue, like you were saying, than structure-borne, stuff coming up through the floor.
Is cover on a problem?
Huh?
Is cover on a problem?
It depends on the design of the cover, I think. I think some covers are kind of flimsy, and it's usually worse if it's on. Like a 1200, Technics 1200, just take it off when you're playing the thing. It's very easy to slip it on and off, so. And then I think we're going to pass the microphone to someone else. Yeah, there's.
I was curious about
Okay.
your opinion of spring-loaded anti-skating and tracking force devices on, some turntables like duals and techniques, and how accurate they are. And would you recommend more using a scale instead?
You're asking about the relative comparison between the difference in anti-skate mechanisms. Say a spring-loaded versus a magnet versus a string on a.
Some turntables have a wheel on the tone arm for tracking force
okay.
and skating.
Yeah.
And I'm wondering if you found those to be fairly accurate or not.
Okay, so the British designs, like the Rega and the SME in particular, they tend to be more right than wrong with respect to their instructions of, if you're doing 2 grams of tracking force, set it to the 2. Don't believe for a second that you're getting 2 grams of horizontal anti-skate. You're getting 1/10 that amount, by the way. So they tend to do, actually, the Brits tend to do a pretty good job with that calibration, but that calibration always assumes that there's no internal torque inside of the arm, right? Caused by those wires that we talked about earlier, which is why you don't really know what you're going to get until you measure it, which is why I keep talking to people about Wally Skater. Yeah, you don't really know what the answer is until you've measured it. Does that answer your question? Okay. Who's next for that microphone?
So you were talking about isolations and isolation platforms. There's 2 kind of schools of thought with turntables where you have the big, massive things that weigh a ton and the suspended platform types.
Okay.
Compare and contrast.
Compare and contrast. Well, I guess the ultimate of the lightweight approach is Riga, who, as you spend more on their turntables, they get lighter, because they use more sophisticated, lighter weight materials. And their whole thinking is to make the resonances die away very quickly. So if you have a big, huge bell and you hit it, it rings forever. Whereas if you have a little tiny bell that it's very light, made out of aluminum, and you hit it, it dies out very quickly. So they don't want mass loading as the approach. They take a different approach. But in terms of how that affects the platform, the old Lin thing was always a light, rigid platform. And I think there's, I gave him this platform that CWD used to make for Lins. it sold for $50, and it has a screw in each corner with a little spike, and it weighs like 2 pounds. And that thing sounds great under a Lin, but it's not isolating it at all. It's just decoupling it, or not decoupling it, but decoupling it from mass, basically.
Yeah,
So-
I was more talking about the sprung suspended
like a Lin,
turntables.
yeah.
Like a Lin.
Yeah, well, that's the same thing. Is that they for that they like a lightweight, rigid platform. The sort of mass loading approaches tends to be the unsuspended designs.
Given that, the whole talk about rigidity of the platform that it's on, and does that become less necessary with a suspended turntable?
I'm not sure I'm following.
Are you asking if? You're asking if rigidity becomes less important with a suspended turntable?
Rigidity of the support, yes.
Rigidity never becomes less important with mechanical transcription. Rigidity wins, period. All right? Now, the devil's in the details, right? We don't, it depends on where you've got your rigidity as well. Okay. So with the case of the designs you're talking about, which are lightly sprung, and Michael's absolutely right. What Rega is after, and what Lin in part is after, is that if we make things low mass, that's low energy storage, but that doesn't help avoid transferring low frequency mechanical energy to the turntable. The low frequency mechanical energy is, I argue, the most deleterious of all the risks that we face with optimal mechanical transcription. So in order to avoid, but it's much more difficult to avoid low frequency energy transfer than high frequency energy transfer. This plays out in acoustics, where for 1100 cycles, all I need is 3 inches of material. But for 110 cycles, 1 decade less than that, I need 2.5 feet of material to do the same amount of effective absorption. This plays out in mechanics as well. So what they're doing, these lightly sprung designs and Regas, they're doing, well, the right thing to avoid mechanical energy transfer in the higher frequencies. But the lower frequencies, those are, I think, where the real prize are, and that's going to be the difference between a flippin' great turntable and a good turntable.
Yeah. Anyway, we are.
No, there's nobody here at 1, I don't think. Yeah, it's a different room at 1:30. Yeah.
Do you have an opinion about direct drive turntables like the $20,000 Techniques, for example, compared to like a real high-end belt drive turntable? Is there an advantage or disadvantage?
You talking to?
Okay, yeah. So I think the future belongs to direct drive. I think the future belongs to direct drive. Now, first thing, a problem we needed to solve was cogging. That was solved some years ago. Then the next problem that needed to be solved was torque ripple. And now there's actually multiple different ways we can solve for torque ripple. But right now, it's still very expensive to do that. I think in terms of cost versus benefit ratio, the Techniques table offer a fantastic value for the turntable. Belt drive, there's still wonderful examples of belt drive being done. I like the Doman design, the Doman audio design, but I think the future of the best probably belongs to direct drive.
I mean, I think we've been living, direct drive got a bad name in the 70s, and all the audiophile press were saying, direct drive sucks, and for the most part. But there were a few high-end companies that were making direct drive turntables, like Goldmund and Mitch Cotter. And if you look at them, they were all buying parts from other companies and sort of implementing them in their own design. They weren't building a direct drive from scratch. And it was very difficult. It's very difficult. Oops.
Look closer.
Okay. It's very difficult to implement direct drive. It's much harder to put a motor on a plinth and attach a belt. It's pretty simple, To build a direct drive from scratch where the motor is part of the platter mechanism is much more difficult. And I think that stopped a lot of small manufacturers from building them in the past.
Yeah.
And even today, some of the most high-end direct drive turntables you find, you dig in there, there's Technics parts in there, I'll tell you.
Yeah, I think you're right. Yeah. Another question over here.
Back to anti-skate. Do you have an opinion on like the weight on a string versus the mechanical designs for anti-skate?
I like the weight on a string. It's simple. It's elegant. I've seen too many disasters with when people try to get too fancy with that. I'm not saying all of them are, but not by any means. I like the simple, elegant weight on a string. It hasn't reached its optimal expression yet. I'm not going to say anything more than that.
You know, I think mechanical anti-skate can work, or no, magnetic anti-skate can work pretty well. I find the anti-skate on the clear audio pivoted arms works really well.
You provide the force. There's multiple different ways to provide the force. Did you design something that doesn't create another problem, right? And in most cases, the answer is we're seeing good designs out there.
Yeah, but some bad ones too.
Yeah. So,
I have to go into the software game. How do you feel about the softwares that are available for anti-skating alignment, specifically the anti-skating?
okay, you're taking me down a rabbit hole here. It is not possible to measure force with a nonlinear distortion track, which is what THD is. You are measuring at best a third order representation of that. In fact, that particular suite gets a number of the tests wrong because not all distortions are nonlinear. So you can't use THD to measure every type of distortion. So for example, the zenith error it's not a nonlinear distortion, it's a linear distortion. So what are you measuring when you're using THD to measure a timing error? You're measuring cantilever angular. You're not measuring zenith error. And then the next question should be, which is more audible? Angular error of the cantilever or zenith error? Well, I talk about this in my videos, and that's a very obvious one. So the ear is much more sensitive to timing errors than the small amount of added secondary harmonic distortion created by cantilever angular error, right? So with respect to anti-skating, I cannot see, I have tried to divine any reasonable way that one could use a test record and analyzing its output to measure, are the torque forces balanced? And I can't come up with a good answer at all. I don't think it's possible. Yeah.
I think we're out of time.
Yeah. Thank you.
Thanks, everyone.